Row 1. Text, Notepad window, text editor, editing. Blank. Remember blank. Remember selected, blank. Remember this is not teaching man teacher selected. It is useful for recalling when exam coming man student. Just close eyes and listen. Based on G scheme for Electronics Engineering Group. Subject, Mechatronics, 17,660. These are mostly important questions which is always repeat, form top. To end it reduce repeated changes. X question 1 is more important than 2 in notes. And note warning sign that this is not all chapter. Download link is below.
One. Mechatronic Chapter 1. 1. Explain the scope of mechatronics in industry. Give any 4 examples. X1, ANS, scope 2 marks, example 2 marks, scope. There is no limit for scope of mechatronics in industry. Due to mechatronics speed, quality, flexibility, sophistication, and quantity of product has improved drastically. Marketing of product has also become simple. It has increased accuracy in design, for example production of machine tool through CNC machines more accurate and precise than conventional lathe. Similarly, quality and hygiene of food product due automation and robotics in packing industry has improved. Due to embedded system, domestic machinery has become simple and user-friendly. Automobile industry has become more sophisticated as well as user-friendly. Due to application prompt sensors, accident of automotive vehicles are less. The use of automation in hospital diagnosis of diseases has become simple. Not only that, but doing the telehealth care is also possible for patient. Examples, sad face, NE4. MRI, CT scan, endoscopy, robotics, unmanned air vehicle. 2. What is the significance of signal conditioner? Explain the need of following in mechatronics system. I. Isolator 2, filter 3, amplifier 4, data converter, X4. ANS, significance, for marks, need, 1 mark each. Significance, signal conditioning means manipulating an analog signal in such a way that it meets the requirements of the next stage for further processing. Signal inputs accepted by signal conditioners include DC voltage and current, AC voltage and current, frequency, and electric charge. Sensor inputs can be accelerometer, thermocouple, thermistor, resistance thermometer, strain gauge or bridge, and LVDT or RVDT. Specialized inputs include encoder, counter or tachometer, timer or clock, relay or switch, and other specialized inputs. Outputs for signal conditioning equipment can be voltage, current, frequency, timer or counter, relay, resistance, or potentiometer, and other specialized outputs. It is primarily utilized for data acquisition, in which sensor signals must be normalized and filtered to levels suitable for analog to digital conversion, so they can be read by computerized. 2. Mechatronic Chapter 1. Devices. Other uses include pre-processing signals in order to reduce computing time, converting ranged data to Boolean values, for example, when knowing when a sensor has reached certain value. Isolator. Signal isolation must be used in order to pass the signal from the source to the measurement device without a physical connection, so that input will not load next stage. Optical isolator may be used. Filter. To filter out noise due to environment, or any other reason like MEC, or 50 Hz noise amplifier. Signal amplification performs 2 important functions, increases the resolution of the input signal, and increases its signal-to-noise ratio. For example, the output of an electronic temperature sensor, which is probably in the millivolts range, is probably too low for an analog-to-digital converter, ADC, to process directly data converter, to convert data into particular form as required by the load. They may be of following type: analog-to-digital converters, digital-to-analog converters, frequency converters or translators, voltage converters or inverters, frequency-to-voltage converters, voltage-to frequency converters, current-to-voltage converters, current loop converters, and charge converters. 3. Explain the Mechatronics system with the help of block diagram, and labeled the various elements. X7. ANS, block diagram 2 marks, explanation 2 marks. The key elements of Mechatronics systems can be classified under following categories: information systems, mechanical systems, electrical systems, computer systems, sensor and actuators, real-time interfacing. Explanation 2M. Mechanical systems. Actuators. Actuations is the result of direct physical action on process directly. In any physical process, there is motion or some sort of action. This motion or action can be applied to mechanical processes or structure through actuators, e.g. stepper motor, solenoids, DC motor, synchros, etc. 3. Mechatronic Chapter 1. Sensors. It accepts the physical quantities, process variables, from mechanical processes, dynamic system, and converts them into a signal that can be processed by the system. Block diagram 2M. Electrical systems. Input signal conditioning and interfacing. The output of a transducer may be too small, too noisy, contain DC offset, not be compatible with next stages, and contain wrong information. Signal conditioning process if amplification using amplifier, in which the signal magnitude is increased. Digital control architectures. PLCs are industrial devices used for interfacing and controlling analog and digital devices. Microcontrollers are low-cost, versatile, small size and easy programming device. Graphical displays. Various types of graphical displays are used for displaying measured variable, outputs, voltages, etc. Waveforms can be displayed for various analyses by CRT. Controllers. It takes input from output signal conditioning and interface, and it is not equal to the required set points, then it is adjusted based on generated error, and again signal is given to actuators and sensors. 4. What are advantages and disadvantages of Mechatronics system? X3. ANS, advantages of Mechatronics system, 2M. High level of integration. Increased functionality and better design. More use of electronics and software instead of mechanical function. Assumes responsibility for process and operation, with little interference of operators. Uses artificial intelligence and intelligent process control. Multisensory and program environment. 4. Mechatronic Chapter 1. High reliability and safety. Improved and less expensive controls. Disadvantages of Mechatronics system, 2M. The initial cost is very high. The complicated design and system. The repair and maintenance is complex. Its replacement is difficult, that it is difficult to change old system to new system. 5. State and elaborate the importance of mechatronics in various field of engineering. X3. ANS with the recent advancement and development of digital circuits and computer-aided design and manufacturing has led to considerably improvement in many industrial production and in research as well. With the available automation and control methodologies, Along with integrated embedded/VLSI technology, mechatronics has become relevant to industries, machineries, and computers products. Automation and control represents a broad topic with applications in many disciplines, including production, industrial and manufacturing engineering, process control, robotics, instrumentation, home automation, and many others based upon sophistication, flexibility, and state-of-art technology. Mechatronics has already emerged to cater to the need for sophistication and flexibility, and in fact has become a preferred choice for the current generation of real-time automation and control and solutions for traditional mechanical systems. The engineering disciplines are now dilating instead of diverging because of requirement of interdisciplinary knowledge at the production place. The upgrowing multidisciplinary subject mechatronics is widely used in production houses by the engineers, research scholars, designers, and academicians as well. With the advancement in digital technologies, cost-effective VLSI and ASIC design, simulation softwares, advanced networking solutions, real-time tools and techniques, and many more, this field is growing very fast. 5. Mechatronic Chapter 1. 6. Explain the evolution of mechatronics. The term mechatronics was invented by a Japanese engineer in 1969, as a combination of mecha from mechanisms and tronics from electronics. The word now has a wider meaning, being used to describe a philosophy in engineering technology, in which there is a coordinated, and concurrently developed, integration of mechanical engineering with electronics and intelligent computer control in the design and manufacture of products and processes. As a result, mechatronic products have many mechanical functions replaced with electronic ones. This results in much greater flexibility, easy redesign and reprogramming, and the ability to carry out automated data collection and reporting. A mechatronic system is not just a marriage of electrical and mechanical systems, and is more than just a control system. It is a complete integration of all of them in which there is a concurrent approach to the design. In the design of cars, robots, machine tools, washing machines, cameras, and very many other machines, such an integrated and interdisciplinary approach to engineering design is increasingly being adopted. The integration across the traditional boundaries of mechanical engineering, electrical engineering, electronics, and control engineering has to occur at the earliest stages of the design process if cheaper, more reliable, more flexible systems are to be developed. Mechatronics has to involve a concurrent approach to these disciplines rather than a sequential approach of developing, say, a mechanical system, then designing the electrical part and the microprocessor part. Thus, mechatronics is a design philosophy, an integrating approach to engineering. Mechatronics brings together areas of technology involving sensors and measurement systems, drive and actuation systems, and microprocessor system terms together with the analysis of the behavior of systems and control systems. That essentially is a summary of this book. This chapter is an introduction to the topic, developing some of the basic concepts in order to give a framework for the rest of the book in which the details will be developed.